Hello and welcome to this video designed to give you feedback on your first Rivers mini test. Okay, now what I want you to do is I want you to take out your self-assessment sheets and your test papers, and I want you to follow this through question by question, and then I want you to have a go at redoing the questions that you didn't do quite so well on, and I want you to complete that pink self-assessment sheet which you should have stuck in your books from lessons. Now, the first question on the exam paper asked you for a simple definition for 1 mark, okay? And it simply said, what does it mean by the river's velocity, okay? Well, really simple, velocity equals speed. Now, most of you got this question correctly. When it comes to your exam, if you can pick up these nice, easy 1 markers, it can make a massive difference to your final grade. So make sure that you're revising and that you know some of those key definitions, okay? Now, on the next question, you had a graph, and it was a skills style question that required you to interpret the graph in order to be able to show exactly what was going on. Now, the graph, for those of you that are interested, is called a Holstrom curve. You don't need to know that for GCSE, but for those of you that are doing A-level, you might want to know, and you might want to take note of it. Now, when you're reading the graph, it asked you for the processes that were occurring. So it was either erosion, transportation, or deposition. Some of you put things like saltation, solution, or some of the processes of transportation and erosion. Okay, it was asking you for these 3 processes: erosion, transportation, and deposition. Now, the graph looked a little something like this. Okay, so if I just zoom in on it, you can see it nice and clearly. Okay, now the question simply said, using figure 4, which river processes will occur when the riverbed is sand and the velocity is 100 centimeters per second. So what I'm going to do is I'm going to have a look here where I've got sand, and then I'm going to read up the scale to where we've got 100 velocity, also 100 centimeters per second. Okay, you can see that on the Holstrom curve it's telling us that if that's the case, the particles will be eroded. Okay, so you've got to take care. Make sure you use those exam skills. Make sure you're looking at the titles of graphs, looking at the axis, and reading it off 1 step at a time. Okay. Right, moving on then. The next questions asked you about processes. The first question asked you about the processes of erosion. Now, some of you are forgetting some of these key pieces of information. Remember, there are 4 processes of erosion. You've got hydraulic action, which is where air is forced into cracks by the sheer power of the water. You've got attrition, where smaller particles hit together to become smoother, smaller and rounder. You've got abrasion, where rocks will be thrown at the bed and the banks of the river. And then finally you've got solution, which usually dissolves sort of limescale, calcium carbonate style rocks. Okay, so dissolving it using the acidity of the water. Some of you put vertical and lateral. That's not wrong, but I was a bit harsh because the mark scheme only specified for the 4 main types of erosion that we've talked about. Now, the next question was a process question as well, and some of you are not sure on your processes of transportation, and this is where revision really comes into it. So you've got 4 processes of transportation. First one is saltation, and this is where particles and pebbles are bounced along the riverbed. Solution, very similar to the erosion, it's where you've got dissolved particles being carried along by the flow. Suspension is where something is suspended in the water, so in other words, it's not touching the bed or the banks. And then you've got traction, which is where large particles are rolled along the riverbed, okay? You need to make sure that you understand these. This is where revision comes in. Draw yourself a mind map, okay? Put the different processes of transportation in there. Come up with a clever way to memorise how each of them work, okay? And keep going until you can do them all from scratch, because that's 4 easy marks in the exam that could make a significant difference to your final grade. Okay, the next question then that we move on to showed you a picture, and that image was of a meander. Now, most of you understood that it was a picture of a meander, but what you didn't understand was what was happening at the edges of the meander, be it the inside bend or the outside bend. So what I've done is I've drawn here a cross-section of a meander. Now, remember, a cross-section is when you slice into something. So if I was going to have a cross-section of a bit of cake that was Victoria sponge, okay, I'd slice into it and I'd be able to see each of the different layers, and that's what we can see in this diagram here. Now, there are 2 bends to the river. There's the outside bend and the inside bend. Okay, now the water, or the high velocity water, always goes to the outside bend of the river, and because it's higher velocity, it's got higher energy, so we get erosion on this outside bend. Okay, make sure that you get it the right way round. Now because it erodes on the outside bend, we end up with a feature which is called a river cliff. Now no one started talking about the features that we see to get those extra marks. So river cliff, and you can also see this feature here on the inside bend, which is a slip off slope. Now if the energy is higher on the outside bend, it's lower on the inside bend, and obviously if there's less energy, the river can't carry much, so it drops it or deposits it. So I've put deposition there, and it creates this feature which is a nice little slope of shingle, which is called a slip off slope. Now the final question in the exam asks you to explain how a meander forms. Okay, now one of the things that people are still not doing is when you're looking at physical processes questions, you need to sequence your answers. Okay, so what I've done is I've drawn a bird's eye view of a meander, and you can see the fastest flow on the outside, and you've got this deposition on the inside, and these lines are little embankments which are going to tell us where our river cliffs are. So what I've done for the 5 marks is I've broken it down into 5 steps. So the first step that you've got there is that the current is strongest towards the outside bend. Higher energy and velocity encourages erosion, and I've even been clever and put 2 names of erosion, abrasion and hydraulic action. Okay, and a river cliff is formed. The inside bend has lower energy or a lower velocity. This encourages deposition and forms a slip-off slope. Okay, so it's simple. 5 marks. You've got to make sure that you sequence it. Point 1, point 2, point 3, point 4, and point 5. Now, this wasn't on the exam, but I thought it would be a little bit neglectful of me if I didn't mention Oxbow Lakes. You could get asked a question similar to the meander question, but about Oxbow Lakes. So here, I've sequenced the process again. So you've got a similar diagram to that first one that I drew. You've got the erosion continuing on the outside bends of the river. Eventually, okay, that gap gets narrowed, and they will join up and the river will break through, forming that fast-flowing, steep, straight channel and leaving the old meander, which is called an Oxbow Lake. Remember, sometimes these meanders can dry out and they form what we call meander scars. Finally then, you'll be keen to know what the grade boundaries were for this test, okay, and you can see them there in front of you. Remember, you can rewind this video, you can pause it, you can watch it as many times as you like, redo the test and get those self-assessment sheets filled in. If you're still not sure on what you need to do, come and find me. That's what I'm here for. It's my job. I want you to get the best grade that you possibly can.